All right, in this video, we are going to work this limit problem involving an algebraic function. All right, so this is the limit as x goes to 6. So we're going to plug in 6 and see what we get. Okay, so when I plug 6 into the top, I get 6 cubed minus 6 times 6 squared. On the bottom, I get 8 times 6 plus 2 minus the square root of 10 times 6 minus 10. All right. And then keep working that out. On the top, 6 cubed, 216, I think, but it really doesn't matter because 6 cubed, whatever it comes out to be, because this is also going to be 6 cubed. Right, because that would be 3 6s, right? And so that comes out to be 6 cubed on top. So that's going to give me a 0, right, on top. On the bottom, I have 8 times 6, that's 48, right? Plus 2 is 50. On the bottom, I have 10 times 6, that's 60. 60 minus 10 is also 50, right? So on the bottom, I have square root of 50 minus square root of 50. That's also going to give me 0. So I have 0 over 0 format, right? And that's an indeterminate form, right? It's never the correct answer on these types of problems. So what we've got to do is try something else, right, other than plugging the number in. Looking at this function, right, we said this is an algebraic function, right? It has these square roots in here. And so what we're going to do is to rationalize, in this case, the denominator. This is where the square roots are, so we're going to move them up here using the exact same technique that I showed you in the previous video. Okay? All right. So let's go ahead and get started on that. So we have the limit as x goes to 6. X cubed minus 6x squared over the square root of 8x plus 2 minus the square root of 10x minus 10. Right? And what we are going to do is multiply both the top and the bottom by these same square roots, right? But instead of being joined by a minus, we're going to join them with a plus. So we're going to change this subtraction to addition. And remember that what that is going to do is it is going to get rid of all of the square roots in the denominator, all right? And then, but to keep things balanced out, we can't just multiply the bottom by this expression. To keep everything balanced out, we will have to multiply the top, right, by that same expression. Otherwise, we'd be changing the values, and we can't do that and expect to get the correct answer, right? The same answer to the original problem. All right, so by multiplying the top by the same expression, we preserve the value because this is essentially a 1, okay? All right. Now, I'm going to carry out half of these multiplications, not all of them, okay? And again, that's one of the keys to this problem, just like I explained in the last video. Here is, in the denominator, right, is where the square roots were in the original problem. So go ahead and do this multiplication because this is designed to clear all those square roots away. All right, on the top, though, don't actually do the multiplication. Okay, that's going to make things more complicated if you do that. So on the top, just leave those factors equal to each other, right? I have x cubed minus 6x squared, and I'm just going to be timesing it by this factor here, square root of 8x plus 2 plus square root 10x minus 10. Okay, and that's going to be the numerator of the top, or the numerator of this fraction, the top of this fraction. All right. Next up is actually, you're going to actually carry out these multiplications on the bottom, right? So on the bottom, these two binomials have to be FOILed out, right? So it's going to be first times first. So I'm going to multiply square root of 8x plus 2 times the square root of 8x plus 2. And since it's the same expression, right, underneath the square root, right, it's just going to be x plus 2 down here. All right. And then, again, just like in the previous example, right, the outer and the inner will cancel each other out, right? So I'm going to go ahead and put that step in there. A lot of times when I'm just working these out myself, I don't write this step in here, but I'm going to show this step, right, just so, again, you understand what exactly is going on. So I'm multiplying these two binomials out, so I do the outer one here times the outer one here. And then I do the inners, right, the inner ones here and here. And you're going to see that, you know, they have exactly the same square roots in that expression, right? Except with completely opposite signs, right? They both have a square root of x plus 2. They both have a square root of 10x minus 10. This one has a positive 1 out in front, essentially. This one has a negative 1. So that means I have one of these, right? And then I take away 1. That will give me 0. So these are going to cancel out each other out. They are the dead opposites of each other. All right, last times last, right? You got to be very careful about this one, right? So I have minus 1 times the square root of x minus 10 plus 1 times plus 1 times the square root of 10x minus 10, right? So that is going to come out as a minus 1. And what you've got to remember here is that that 10x plus, or minus 10 rather, needs to go inside of parentheses, okay? It is a mistake not to put that on there. All right, so what you will see is a lot of people forget to put these parentheses on there, and that will cause you to get the wrong answer. So that mistake is just one of the most common mistakes that people make on this. So you've got to remember not to make that mistake. Okay. All right, next up is now do some simplification. On the top, again, there is not a lot that you want to do in this problem, right? Just leave those expressions alone for the time being and work on where the square roots were in the original problem. In this case, they were in the denominator, right? So that's where we want to do most of our work. Okay, so I have this 8x plus 2. Remember, these are going to cancel each other out. I have 1 square root 8x plus 2 times square root 10x minus 10 minus 1 square root 8x plus 2 times square root 10x minus 10. So all of these, right, just drop out right here. And then critical, right, is to distribute this negative through the parentheses here and here, right? So down here you will have minus 10x plus 10. Okay. All right, next we keep working this out. So on the top, we're just going to leave this alone, not do much with it. And keep simplifying the bottom. And what's going to have to happen here is that something, right, is going to have to cancel out in this problem. And we know, right, something that's on the top of the original problem has to cancel out. Right, so something related to this x cubed minus 6x squared is going to have to cancel out. So that's what we're looking for. So on the bottom, we will just keep working through. So we have 8x minus 10x That's going to be minus 2x. And then we have 2 plus 10 is 12. Okay, so we've got the bottom part completely simplified out. And so what we are looking for when you do this rationalization technique with these algebraic functions and these problems, what you are looking for is something to cancel out between the top and the bottom. Here it is not obvious at all what cancels out, okay? So what we're going to have to do is to factor this a little bit more, okay? All right, and now, you could do that in the previous steps. If you wanted to, I just chose to wait to here to do the factoring. Okay, so looking at this polynomial, I want to factor it. Remember, the first step in factoring is to factor out the greatest common factor, which in this case is an x squared. So I can factor out an x squared. Again, the rest of this is just going to sit there, and we're not going to do much with it until the very end. On the bottom, I'll need to do some factoring there as well. And again, right, the first step in factoring is to remove the greatest common factor. So the greatest common factor down in the bottom is a -2. So if I factor out a -2, I get x minus 6. And there you can see, right, that opens up, and finally we see the common factor right between the top and the bottom, and that is going to be this x minus 6. Okay, so now we can cancel that out. All right, and then rewrite it. So I'm going to have to erase a little bit of this. So I think I'm going to start erasing right here. All right, so what we'll have is x squared, and we'll have this square root 8x plus 2 plus square root 10x minus 10 on the top. On the bottom, all we have is a -2. Okay. Okay, so now what we're ready to do is, now that something canceled out, what we want to do is to plug in the 6 again and see what we're working with. Okay, and it's obvious, right, that we are not going to get 0 over 0 this time, because on the bottom we know 100% we're going to get a -2 on the bottom. Okay, so plug in, and we know we get -2 here. Plug in that negative, or the 6 into the top, we get 6 squared times square root of 8 times 6 plus 2 plus 10 times 6 minus 10. Okay. All right, keep working. Oops. Reset -2, so it goes here. Okay, so keep working that out. I think I'm just going to start erasing over here. I'll just kind of work down this side here. All right, so simplifying that out, right? I get on top, right? I have a 6 squared, right? So that's 36. All right, and then underneath these roots, we have 8 times 6, that's 48, plus 2 is square root 50. And here I have 60 minus 10, that's also going to be square root 50. And then on the bottom, I have minus 2. Okay. All right, and so we can just keep working that out. First off, negative 2 will go into itself once, right? And go into 36 minus 18 times. So I have a minus 18 out in front. Inside the parentheses, I have square root 50 plus another square root 50. So that's 2 square roots of 50. All right, and then 2 times a negative 18 will be minus 36 square roots of 50. All right, and then in this problem, we have to make sure that this root is reduced as much as possible. Okay, so it can be reduced. You're looking for the largest perfect square, right, that will go into 50, and that's going to be 25, right? So this is 25 times 2. So this is going to be the square root of 25 times the square root of 2. And the square root of 25 is just 5, okay? So I wind up with minus 36 times 5, which is negative 180 times the square root of 2. All right, and that is it for this one.